Hi, we are going to continue our discussion on the articulated Cartesian arms and how they're being used in the mechanical equipment configurator. Now this given family added one more level of functionality that we haven't discussed yet, and that's shifting the reference point of the arm in the family. So we all know, well, I guess if anyone looks at dimensions on cut sheets, you'll find that every manufacturer dimensions the openings from a different reference point. You know, nothing's ever the same, and that's nothing wrong on their part. Some will use the bottom left corner, some will use the top right corner. You know, so we need flexibility to be able to pull an X, Y, and Z coordinate off a cut sheet and use the reference point that they're using. This actually came about because someone in my office, Drew Erickson, who's a great new engineer that we have, he comes up to me and he was looking at this family and he's like, well, why don't you just make it so you can change the reference point? And I sat there, just kind of stumbled on my words for a little bit, and I'm like, well, because it's not that easy. But, you know, it turns out that I figured out a way to do it. So for all of your guys' benefits now, we can change the reference point, which really only can be done in a clean way with lists. So this family now, we've got every arm set up, all the connectors set up. I'm just going to get rid of these, you know, for the time being so we can see the family a little better. So we'll leave some of these arms for the time being. So let's say we're working with an air handling unit. So chilled water coil, heating water coil connectors, condensate. We're not going to need this exhaust arm, so I'm going to delete that. However, we may want the vent arm to add a outside airflow connection to a mixing box. All right, so here's the arms that are left. Typically, my process for creating new families is to first strip down the parameters that are in this family, because this family, in all honesty, contains every parameter found in the mechanical equipment schedules, because we've sorted them and organized them, so we had to do that here. So they're all here to begin with. I'm not going to spend the time removing them right now, so this family will chug a little bit, but rightfully so, because there's tons of formulas and tons of functionality in it. All right, so let's say, for example, let's see, what's the best way to, okay, so let's talk about making an air handling unit from this family. So I'm going to go up to my construction where I control what arms are being used. So we're going to have a supply fan, a return fan. We are not going to have energy recovery. Okay, we're going to have a heating coil right there, and we're not going to have a gas-fired heat exchanger. So choosing these boxes essentially goes into formulas and determines which arms are going to be used based upon these connectors and these settings. So let's see what else is here. And then heat exchangers. So a roof curb we're not going to have. I'm going to turn that off. Well, let's keep it. So we'll keep it for the moment, and we'll say that this is a rooftop air handling unit. And that's all we need to do there. So let's hit apply. Now, if the gas arm was here, it would have went away. This vent arm went away because we didn't check that we have outside air. So if the equipment needs an outside air connection, let's hit apply, and we can use that arm now, and we can make this into a mixing box of sorts. All right, so let's hit apply. And we have a hood on that arm, which is one example of showing that you can use these arms for geometry as well. It's really for the rooftop units, because this would represent an economizer connection with an economizer hood. So we'll be deleting the hood for this example. All right, so let's flex our arms now. So the one thing that's changed is the ability to change a reference point. So I'm going to start off by editing our equipment length, width, and height. So let's go 10 feet by 5 feet, and let's call it 6 feet high. So I'm going to hit apply. That's going to flex the unit, it's going to flex the curb, it's going to flex our clearances and everything like that. Now I'm going to filter this parameter list, and my recommendation is to write what you want to filter by, specifically in this configurator, in another window, and then paste it in. Because otherwise this family will chug, and you'll understand when you look at it at how much is going on in this family. So let's just filter down to our inlet duct connection. Generally speaking, everything down in other are hidden parameters that users won't see in the project, and that, in all honesty, you don't need to see in the family either. So those end up in other. And then here's our sets of parameters. So what we haven't discussed is this reference point. So for this unit, let's give it a bottom connection, since it's an air handling unit on the roof. So let's go 24 inches, and then let's call it 20 inches. So we can use a duct depth if we'd like to. I'm just going to keep it at 2 inches. And now here is this reference point that I've referred to. So at the moment, we're on the bottom face. X is at 0, X is at 3 feet, Y is at 5, and Z is at 0. And these are coming from the origin of the family, which is typically the intersection of the two center planes. So I'll change these to 0 so you guys can see where the connector is at right now. So we should be right in the middle of the family, at the very bottom of it, with the connector on the bottom side of that. So let's hit apply. All right, so now say we have a manufacturer that dimensioned this off of a corner of the unit. So we can choose the front right corner, which is right here. We can say, hey, let's not have our reference point be the origin. Let's choose a corner. And when we do that, now all of our X, Y, and Z coordinates are going to be based upon that. Now, does that mean that we shifted the location that the family is pinned to? No, the family is still pinned to the origin. The arm is at the origin, but we've developed some calculations now that are looking at equipment geometry, length, width, and height, to determine this correction factor. So we're at the front right corner. Now we could say this manufacturer dimensioned it from this corner, and we're going to go negative now. Let's go negative 2 feet, and let's do a positive Y, which is now going to shift it back. Let's do a positive Y of 1 foot. So that is the reference point functionality that I have to say, courtesy of Drew, of asking the question, well, why don't you just allow users to change your reference point? So there's that connector. Let's do the outlet duct connector. So once again, I've typed these words in a different window for your guys' benefit. Okay, so let's go bottom face on the, sorry, this is the discharge of the supply air out. We just did the return. Let's give it a size again, 24 by, sure, we'll go 12. Although a lot of times these supply connections are more square than rectangular. So let's make it 24. The outlet duct diameter is in this family, but it's stripped out for families that don't have round connectors. So that's why it's there. And now, sticking with the concept of reference point adjustment, let's change this to the back right corner. All right, so minus 2 feet. So now we're coming from this point here on the unit, and let's do now a negative Y. So let's go minus 3 feet. All right. There's our second arm. So I didn't show you guys this before too, but when the duct connections are on the top or the bottom, we're able to rotate that around. So if we go back to the inlet duct connection, I chose that one because it's less of a square. And if we wanted to rotate the connection, so we hit apply and the connector rotates. So this allows tremendous flexibility with combining many different sizes of families with connectors this way and that way. So I guess let's just finish off the last piece here, the vent duct, which represents our outside air to the mixing box. So yes, the connection's being controlled, the arm is there, the description is outside air. So let's put this one on the, let's just go right face, and let's give it a size. So let's say it's 18 by 30. And let's change our reference point to be similar to the return air duct connector. So let's base our dimensions off of the front right corner, which is this corner. And now we are going to not change the X. We're going to keep it on that face, on the right face. So we're going to put that at 0. And we're going to change the Y. We're going to shift it up a little bit. Let's shift it up 2 feet. And let's hit apply at this point. There we go. So we have a hood on this family, which we can change, which we'll talk about down the road. But essentially now you're left with, so the Z with the 0 value took the middle height of the piece of equipment from here to here. So there we go. That's the mechanical equipment configurator with adjusting the arms, the duct connectors in this scenario. So once again, the families in the content package have been whittled down to only what you need. So they function, they're much lighter than this family here, but this family has its purpose. So now hopefully with these families, we can start to create these universal families that can fit any manufactured cut sheet, which is beneficial for firms that maybe aren't using manufactured content, or maybe manufactured content isn't available for a given manufacturer. You have something that you can look at a cut sheet and turn it into a family, ideally in not a lot of time. So thanks.